At 11:48 p.m. Pacific Time on October 19, 2025, a database endpoint disappeared in Northern Virginia. Not the database, not the servers holding its data. The public answer to a basic question disappeared. Where is Amazon DynamoDB in US East 1? Its regional DNS record contained no IP addresses. New connections had nowhere to go. Customer software failed, and AWS control systems that depended on DynamoDB began failing with it. What followed unfolded in 3 connected acts. First, an empty address record. Then an EC2 control plane overwhelmed while rebuilding lost authority. And finally, load balancing automation removing healthy capacity from service. AWS's main operational event lasted until the following afternoon. Some Redshift clusters remained impaired into October 21st. The initiating defect was narrow. DNS is the Internet's address book. DynamoDB may be distributed across multiple availability zones, but an application must still translate its stable service name into an address it can contact. At AWS scale, that address book is not static. DynamoDB represents a large load balancer fleet, through hundreds of thousands of records, that change as capacity enters and leaves service. A DNS planner decides what the routing state should be. A separate component, the enactor, makes Route 53 match that decision. 3 independent enactors run across 3 availability zones. Each looks for new plans and applies them through transactions designed to keep every endpoint internally consistent. The architecture was built for resilience. The enactors had few dependencies, so they could keep operating during a broader emergency. But 3 independent workers can share the same coordination weakness. Redundancy multiplied the workers. It did not eliminate the race between them. Normally, an enactor verifies that its plan is newer than the one previously applied, then works through DynamoDB's endpoints. Immediately before the outage, one enactor encountered unusually long transaction delays. Its plan was current when checked, but it grew old as the worker retried and moved slowly down the list. Meanwhile, the planner generated newer generations. A second enactor collected one of those newer plans, applied it quickly, and began normal cleanup. Cleanup deletes plans significantly older than the generation just installed. At almost the same moment, the delayed first enactor reached the public regional endpoint. It applied its stale plan, overriding the newer state. The safety check had been valid when performed, but time had invalidated its conclusion. Then, the second enactor deleted that old plan because it appeared obsolete. It did not know the plan had just become active again. The deletion removed every IP address from the endpoint. Worse, the active plan itself was now gone. None of the 3 enactors could apply a newer plan or repair the inconsistent state. Check, apply, and clean up were each understandable operations. Under one rare ordering, they became destructive. AWS identified DynamoDB's DNS state by 12:38 a.m. Temporary mitigations restored access for some internal services by 1:15, and revived tools operators needed for recovery. At 2:25, AWS restored all DNS information for the public endpoint. Global table replicas caught up 7 minutes later. Customers recovered progressively through 2:40 because DNS resolvers cache answers, including failures, until their time to live expires. The database's primary disruption was over, but systems depending on it had not been frozen in place. During those hours, leases expired, retries multiplied, queues grew, and deferred state changes accumulated. Restoring the dependency did not restore the state of everything above it. The first act had ended. The recovery machinery was already creating the second. Existing EC2 instances continued running. The failure was in the control plane responsible for launches and state changes, not in the machines already executing customer workloads. EC2 managers maintain time-limited leases over physical hosts, which AWS calls droplets. A lease establishes which manager has authority over a server and prevents 2 managers from controlling it at once. Renewing those leases required DynamoDB. As the endpoint remained unreachable, leases across the regional fleet expired. When DynamoDB returned, each affected host without a lease had to establish authority again before EC2 could safely use it for new launches. The hardware could be present and healthy, while the control plane reported insufficient capacity. The recovery workload was too large. Leases expired before managers could finish rebuilding them. Timeouts generated retries. Retries in large queues. Longer queues caused more timeouts. The system entered congestive collapse. Additional recovery work reduced, rather than increased forward progress. AWS had no established procedure for this exact regional state. At 4:14 a.m., engineers throttled incoming work and selectively restarted manager hosts, clearing queues and allowing lease creation to outpace expiration. By 5:28, leases had been restored across Northern Virginia. Launches resumed, but protective throttles remained. Removing them too quickly could have triggered collapse again. A launched instance is not necessarily a reachable instance. EC2's network manager must propagate routes, addresses, security state, and other configuration across the customer's virtual network. During the lease failure, those changes had accumulated. As EC2 recovered, the network system began processing a regional backlog. By 6:21 a.m., propagation latency was rising. New machines could exist before the surrounding network knew how to reach them. The NLB health check system brought newly launched instances into service before their network state had fully propagated. NLB nodes and backend targets could be healthy, yet temporarily unreachable to the checker. One test failed. Another succeeded. Capacity was removed from DNS, restored, then removed again. This flapping created more health check work, degraded the checking system itself, and activated automatic availability zone failover. Entire slices of capacity could be withdrawn, even when the underlying infrastructure was healthy. At 9:36, engineers disabled automatic NLB health check failover, allowing available capacity to return. Network propagation normalized at 10:36. EC2 limits were then relaxed gradually and fully removed by 1:50 p.m. NLB's automatic failover was restored at 2:09. A protective mechanism had mistaken delayed information for failed infrastructure and acted on that mistake at scale. Above those control loops, each service failed according to its dependencies. Lambda lost function operations and event processing, then suffered a second capacity shortage when load balancer failures terminated internal instances, while EC2 launches remained impaired. Container services could not launch or scale workloads normally. Amazon Connect turned infrastructure loss into failed calls, busy tones, routing errors, and dead air. Temporary credentials from the security token service degraded twice. Console authentication failures prevented some customers from signing in, including some attempting to work outside Northern Virginia. Redshift recovered its basic APIs and queries after DynamoDB returned, but expired node credentials had already triggered host replacement workflows. Those workflows stalled when EC2 could not launch replacements, leaving some clusters impaired until 4:05 a.m. on October 21st. A separate Redshift defect also depended on an IAM API in Northern Virginia, blocking IAM credential queries in every AWS region. Even AWS support failed over and still denied legitimate users because an account metadata subsystem returned invalid answers rather than no answer. The fallback had been designed for silence, not an invalid response that still arrived as an answer. AWS disabled the DynamoDB DNS planner and enactor worldwide, pending a repair to the race and safeguards against applying an incorrect plan. It announced limits on how quickly an NLB may remove capacity, new tests for regional EC2 lease recovery, and EC2 data propagation throttling tied to backlog size rather than incoming work alone. Those changes address different stages of one causal chain. A delayed worker made an old truth current. Cleanup deleted the truth recovery needed. Lease renewal overwhelmed itself. Deferred network state arrived late. Health automation interpreted delay as failure and withdrew good capacity. No single mechanism explains the whole outage, because each stage transformed the state inherited from the one before it. Redundancy is not merely a count of workers or availability zones. It also requires control over which generation of truth those workers may apply. A queue can become a second outage. A health check can become an actuator. Regional isolation can be broken by one hidden identity or metadata path. On October 20th, the database came back first. The cloud around it needed hours longer to remember how to move forward. Recovery machinery is not outside the system.